We are doing 2.3 sum and difference rules. And let's maybe talk a little bit about this. If you take a look at this one over here on the left, remember this notation, the derivative with respect to x, that's all that it's saying. And so it's saying d dx of some function f plus g. If we want to take the derivative of that, we can actually take the derivative of each separate function. That's all that that's saying. So to tell you the truth, this is why I say this every class. We're not really doing anything new today. We're going to continue with what we did in 2.2, but it takes on a slightly different form. And then if we look at this one here, the derivative with respect to x of f minus g, well, you can separate the two functions and just take the derivative of each term separately. That's all that this is saying. So let's take a look at what this would look like in an example. So in this first example, I've chosen one with like a million different terms so that we get to practice all of it. Well, we're starting off fairly nice and straightforward because according to this rule, if I want to take or find f prime of x, then what that means is I can just ignore the rest of it and just do that one term. And at this point, I feel like we're probably pretty good with this. We don't need to write every little thing out. What would the derivative of this be? 15x to the 4. Everybody good with that? We pulled the exponent down, multiplied it by the coefficient, and then we just took 1 off the exponent. Good? Then we move on to this next one, and it would be plus, and we're going to do the same thing here. What do I get when I take the derivative of this thing? 4 root 2 x cubed. Good? Then we move on to this term. So you see what I mean, that we're not actually really doing anything new. It's like yesterday, but we just know that we're taking, yesterday we just focused on one term. That's the only difference, I guess. Here, what would we end up getting? We would multiply 3 times 1 over 2, so we're going to get 3 over 2 x squared. And here, we would get minus, again, it's pi times 2, so I can say 2 pi x. We usually write the coefficient before pi and leave it in that form. And then at the end, this is I'm out of colors, everybody. Like, this is very stressful. What is the derivative of 5? Well, then that worked out conveniently. We don't need a color. Good? That's kind of it for today, but I will show you, I like to pick out some different forms that this could show up in. I'll be honest, when we look at this next example, there's a number of different ways that we could solve this, but as of right now, let's use what we've learned about derivatives. So if it says f of x and we are looking for f prime of x, then, well, applying the sum and difference rule, what we learned today, the way that this is, it's all jumbled up together, and we know because of BEDMAS or exponent laws, I can't do anything with this the way that it is right now. So the best way for us to deal with this is just to expand and distribute this out. So we could do 2x minus 1 times 2x minus 1. And you all know how to do that. 4x squared minus 4x plus 1, when we multiply those two together. And so we haven't, sorry, I should get rid of the f prime on that. It's still just the regular function we're working with. So now I have it set up or spread out into separate terms. So it's quite easy for me to go through and just to be able to take the derivative of each of them. For this first one, we see that it would be 8x. For this next one, we see that it would just be minus 4. And then we know that with the plus 1 at the end, whenever we have a constant, the derivative is just 0, so it's gone. So we don't have to worry about it. So the only added step, again, is sort of just review or old stuff, which is expanding out those brackets, getting the separate terms, and then just taking the derivative of each term. Yes? You mean like in this case factor? Okay, that's a really good question. So it kind of depends on what we're doing, but if we're just coming up with an answer, I would prefer that you leave it like this and not put brackets in. But it really doesn't matter. If you were to factor out the 4 and rewrite this, that would also be correct. So it doesn't matter. Yeah. Good? We often factor things because through that factoring, we look to simplify or cross things off. But in this case, we're kind of done and not doing anything else with it. So it doesn't matter, whatever you like. Good? Okay, and then this is similar, except just a little bit more going on. But kind of like in the last one, we can take a similar approach. And I wanted to use the different vocabulary so you're familiar with it. Anytime we see differentiate and a function, it's just saying find the derivative of this thing. So again, in order to find the derivative of this thing, well, as of right now, we've only learned the power rule and then today's stuff, the sum and difference rule. So it's probably, again, going to be helpful or beneficial for us to expand this out. So x minus 2 over root x. And when we do go to expand this out, we end up getting x squared minus 4x over root x plus 4 over, x. So we haven't actually taken the derivative yet. All we're doing is we've just, distributed and multiplied things out and ended up with this after we simplified our terms in the middle. Are we all good with how we got that? Good? So then I feel maybe we could have just not even have done this because I think you're okay with this now, but we're just going to take the derivative of this. We know that when we take the derivative of this, we simply get, we used y in this case, so our y prime would just be 2x in this scenario. And in this case here, well, let's do a little bit of work to clean this up because there's a lot of stuff happening here, right? So what's a good way for us to deal with this? Well, I'm going to, just because I have the luxury of doing this, I'm going to rewrite it like this. So to start with, do you see it's probably easiest if we start to simplify and use our exponent laws to get it down to only like 1x or a base of just 1x there. So what is this going to be? What is it the same thing as? Yeah, I'm sorry, you guys. I'm going to rewind this a little bit. Rewind. You know what I mean. 4x to the negative a half. So we won't take the derivative yet because it's probably helpful for us to do this stuff first. And then plus, if we have 4 over x, it's probably easier if I rewrite it this way. Good? So the reason I chose to rewind or whatever I was doing in that case is because I really mean this. And I saw this as I was walking around helping a few people last day. The mistakes, do you see the potential for the mistakes because of the nitpicky little details? The way to avoid that is actually taking a second to write it out. Yes?
Wouldn't the second term be x to the 1/2 negative 1/2?
Sir, oh, this one?
Isn't it?
It would be like saying x to the, No, you're absolutely right. This is positive. Sorry, everybody. The reason why is, do you see to subtract them? This would be like saying 2 over 2. You're right. Thank you. This would be like saying 2 over 2, right? So when we subtract them, we do get positive 1/2. Thank you for catching my mistake. Good?
No worries.
And then for this first one, now we can start to take the derivative. Do you see that we would just get 2x here? And then when we move on to the next one here, what are we going to get for our derivative when we, well, maybe I'll write it all out for you so you can clearly see what we would get. We would get, I need to, nope, that's not going to do it. I'll just have to move it over to the side. We can work with this. Do you see that we would get 4 times 1 over 2 x to the, now it's going to be negative 1/2? Does that make sense? I think I just jumped the gun on that. And then at the end here, we would get plus, no, well, I mean, we can just change it. Do you see it'd be minus 4x to the minus 2? And then I'll swing it up here so that we can finish things off. When we clean this up, we would end up with 2x, and I guess the only part that we really need to clean up or to do any work on is our second term here, where there was lots of stuff going on. What does that simplify to? What does that end up giving us? Minus 2, right? Over. So minus 2, because we did this goes into there and it's going to simplify. And then that x to the negative 1/2 becomes what in its most simplified form? It's going to be the root x moved down to the bottom. We're all good with that? You see why you learned all the exponent laws and negative exponents and da-da-da over the years? It was so you would be able to work with this stuff. And then the best way for us to give this would be minus 4, and we like to leave it with a positive exponent. So let's move that down and say that this is what our derivative would be after all of that work. Good? Believe it or not, that's our lesson. Here's your work for today.